We talk all the time about writing clean code, right? But what about ethical Git? This isn't some fuzzy, feel-good idea. It's a hardcore professional responsibility. It means making sure every single line of code you push is safe, secure, and, critically, verifiably yours. So let's dive into the checklist you can use to build a fortress around your team's workflow, starting right now.
So why all the fuss? Well, get a load of this. In 2024 alone, GitHub found over 39 million secrets leaked in public repositories. Just think about that. That is an absolutely insane number of unlocked doors leading straight to user data, company financials, you name it. This isn't some far-off theoretical problem. It's happening as we speak.
And here's the thing. This isn't just about someone being a little sloppy. Every single commit is a potential risk to your project's integrity. I mean, look at the GhostAction attack from just last year. It compromised developers by twisting the very version control tools we rely on every single day. So the big takeaway here is that we have to start treating every commit like it's a security critical event. Because it is. Okay, so that's the scary part. How do we actually fix it? Well, we shift from the problem to the solution. This right here is your direct, actionable checklist. I'm going to walk you through a 3-part plan that any DevOps lead, any senior engineer, frankly, anyone who writes code can literally start implementing tomorrow to lock things down tight. First up, part 1, immediate local changes. Think of these as the quick wins. These are the things every single developer can set up on their own machine right now for a huge and immediate security boost. Low effort, high reward. Let's get into it.
So let's talk about the massive difference between a regular old commit and a signed one. You probably think your Git username and email are proof of who you are, right? Wrong. I could, right now, configure my machine with your email and push a malicious commit that looks, for all the world, like it came from you. An unsigned commit just looks like you. A signed commit, on the other hand, that is you. It's cryptographically proven, no faking it.
And here's the best part. It's gotten so much easier. We used to have to mess around with GPG, which was, let's just say, a bit of a headache. But now, you can use the exact same SSH keys you already use to push code. All you have to do is run these 3 little commands in your terminal. The first one tells Git to use the SSH format. The second points to your public key. And the third, and this is key, tells Git to sign every single commit automatically.
Okay, so once you've run those commands, there's just one last thing to do. Pop over to your GitHub settings, upload your public SSH key again, but this time, make sure you choose signing key. Do that, and from then on, every commit you push gets that beautiful green verified badge. And trust me, that badge isn't just for show. It's proof that the code came from a trusted device, and it helps build that essential culture of trust across your entire team. All right, so identity is locked down. That's huge. But what about just plain old human error? Come on, we've all been there. It's late, you're debugging, you quickly hardcode an API key just to get something working, and then muscle memory kicks in, and bam, git add, git commit. It happens. So how do we build a safety net to catch ourselves in those moments? The answer is automation, using an absolutely fantastic tool called pre-commit. The setup is dead simple. You install the package. I'm showing the Python pip command, but it works with any language. Then you create one small config file, and finally you run pre-commit install. That last command is the magic. It painlessly installs a tiny script right into your local .git/hooks folder. And inside that little config file you just made, you drop this in. This tells pre-commit, hey, I want you to use this hook called detect secrets. From now on, every single time you type git commit, this hook acts like a bouncer. It intercepts the command and quickly scans all your files to make sure you haven't accidentally left a key or password lying around. And this is the beautiful result. If you try to commit a file that has some long, random-looking string that smells like an API key, the commit just fails. Instantly, the tool stops you cold, right in your tracks. That secret never even gets a chance to be recorded in history, let alone leave your computer. Now that is what I call proactive security. Okay, on to part 2. Look, having these tools on your local machine is great, but it's optional. It relies on everyone remembering to set it up. To build a real fortress, you can't just rely on individual discipline. You have to enforce these rules for everyone at the repository level. So, head over to your repository on GitHub, go to Settings, then Branches, and set up a protection rule for your main branches, like Main or Develop. You're going to see a lot of options, but there are two checkboxes that are absolutely non-negotiable. First, require signed commits. And second, require status checks to pass before merging. Let's zoom in on that first one for a second. Checking this one box is the game changer. This is the enforcement mechanism that makes everything we did in part 1 mandatory. It means GitHub will literally look at every commit in a push, and if even one of them isn't signed, the entire push is rejected. It's a hard nope. This single click turns identity verification from a friendly suggestion into an ironclad team-wide policy.
All right, for our third and final part, remediation. So what happens if the damage is already done? What do you do about that secret that isn't in your current code, but is buried 50 commits deep in your Git history? The skeleton in the closet.
Now listen up, because this is a super critical point that trips a lot of people up. Just running git rm on a file and making a new commit does not fix the problem, not even close. The secret is still there, living forever in the repository's history, and anyone who's ever cloned that repo has a copy of it on their machine.
So to find these hidden time bombs, we need a specialist. Enter a tool called TruffleHog. It's like a detective for your Git history. It's designed to do one thing and do it well. Dig through every single commit you've ever made and sniff out anything that looks like a secret. You can just run this simple command right on your local copy of the repo to kick off the scan.
Okay, and if TruffleHog finds something, you have two immediate, non-negotiable obligations. First, you rotate that key right away, no questions asked. You have to assume it's 100% compromised and out in the wild. Second, you must rewrite the Git history. Use a tool like Git filter repo to go back in time and completely purge that secret from existence. Only then is the fire truly out. So let's zoom out and put all these pieces together. We've talked about local changes, central rules, and cleaning up the past. When you combine them, you don't just have a few new tricks, you have a completely new, fundamentally secure development workflow. It really all boils down to these three pillars. Number 1, sign. Every single commit is cryptographically tied to a real identity. Number 2, prevent. You use automated hooks to stop human error before it becomes a disaster. And number 3, audit. You scan your history and clean up any mistakes from the past. Sign, prevent, audit. That's your new mantra.
This quote really says it all. The days of saying, oh, security is someone else's job are over. They're done. In today's world, if you have write access to a repository, you are a security engineer. Period. It's on you to protect your code, your company, and your users.
And that really brings us to the final thought I want to leave you with. Take a hard, honest look at your own team's process. Think about how you commit code every day. After going through this checklist, ask yourself, is your workflow really secure enough?